Today we're talking about common derivatives, including the derivatives of polynomials, trigonometry functions, inverse trigonometry functions, and exponential functions. First up is polynomials. We want the derivative of a constant. Let's say c. So c can be any number. 1, 2, 3, 1.2, negative 5/7, etc. The derivative of any constant number is just 0. So that's a must-know fact. And then we have the derivative of x, which is just 1. We also have the derivative of a constant times x. Now that gives us the constant itself. And we also upgrade and we have the derivative of a constant times x to the power of n. Before that we have the derivative of x to the power of n, which using the power rule is just n times x to the power of n minus 1. And lastly, we have the derivative of the constant times x to the power of n, which is c times n times x to the power of n minus 1. So let's talk about trig functions. So these are all polynomials. Now on to trig functions. First up is sine. The derivative of sine of x is, so if I put this in brackets, would be cosine x. The derivative of cosine x, however, is not sine x. The derivative of cosine x is negative sine of x. Then we also have sine, cosine, we have tangent, right? The derivative of tangent x is secant x squared. Now we have the derivatives of cosecant x, and that's just negative cosecant x times cotangent x. We also have the derivative of secant x. That's just secant x times tangent x. And last but not least, we have the derivative of cotangent x, which is negative cosecant x squared. Now let's move on to inverse trigonometry functions. We have, first off, the inverse of sine. The derivative of the inverse of sine of x is 1 over the root of 1 minus x squared. The derivative of the inverse of cosine x is negative of that. And then we have the derivative of the inverse of tangent x, which is 1 over 1 plus x squared. And the derivative of the inverse of cosecant x is negative 1 over the absolute value of x times root x squared minus 1. We also have the derivative of the inverse of secant x, which is 1 over the absolute value of times the square root of x squared minus 1. We also have and last but not least, we have the derivative of the inverse of cotangent to x, which is just negative 1 over 1 plus x squared. And the last part of today's video is about exponential and logarithm functions. So first we have the derivative of a to the power of x. So a can be any number, but it's like a constant basically, kind of. So a derivative of a to the power of x would be a to the power of x times the natural log of a. Now the derivative of e to the power of x is still e to the power of x. And the derivative of the natural log of x is 1 over x. The derivative, and this is specifically for when x is larger than 0. And we also have the derivative of the natural log of the absolute value of x, and that is 1 over x, and this is for when x is not equal to 0. But x might be negative, so we have to take the absolute value to plug x into a log function. And the last one of the day is when we have the derivative of log base a of x equals, and that is 1 over x times the natural log of a. And of course, again, we can only use logarithms when x is larger than 0.